Hello and welcome everybody to today's webinar, as usually hosted by the Open Telecom Cloud Community Portal. Today we have Victor Getz and also Tim, both from the IITS Consulting company together with us. These are a partner of the Open Telecom Cloud, but more about this then in a few seconds from Uli. Uli is also part of this webinar here. He's a customer success manager of the Open Telecom Cloud and most probably a well-known face and name inside of the OTC community. With this, I will lead over to Uli Schneider. Thank you a lot for having you here, and let's have a great webinar.
Thank you, Stefan, for the short introduction, and hello and welcome also to all participants from my side. I hope we brought today a very hot topic to you. I think it's an amazing topic, private ChatGPT on Open Telecom Cloud. And I'm also happy and really proud to see what Victor and Tim reached in this topic in the last 3 months. I think we started after Christmas working on this topic. And I'm also happy to get some insights how you're thinking and working around this topic with large language models and retrieval augmented generations in your projects. And of course, I'm also really happy that parts of your solution will later on handled public available as open source in your famous Terraform Project Factory. So that's all from my side. Thank you, guys. Have a good webinar. And Victor, Tim, it's your turn. Thank you.
Yes, thank you very much. So I will take over. I need to correct you a little bit. It is already available in the Project Factory since I think 1 or 2 weeks. And we are developing as fast as the AI department or like the AI technologies to develop. And I'm really happy and thrilled to make the presentation today because I think we have a really hot and awesome topic. So let's dive into it. So what are your speakers today? My name is Victor Getz. I'm the CTO and co-founder of IITS Consulting. And today I brought with me Tim Delbrugger. He's the head of AI department, and he's like a really genius about the AI stuff. Like AI is not my part. I'm infrastructure and I can bring user stories, but all about the AI related things. Tim takes care about all of the projects, and I'm very happy that he's here today with me. So some words about our company, so that you also see that we are not talking some like juniors. We have very lot of experience in our projects. We are named IITS Consulting. We provide agile development teams, and we was founded 2019. After 5 years already, we have over 130 people are working for us, and I think we are also counted one of the most successful IT consulting startups of the last 5 years, and we have made a lot of Open Telecom Cloud projects, and we also contributed a lot to the open source OTC parts, and part of that we want to make also available to you today, and we'll also show you the stuff. So yeah, what do we see today? First up, I will do a little bit technical, like 2 minutes, because I need to spin up the Kubernetes into GPU nodes. So basically we need power to do our LLM stuff, and we will start absolutely from fresh inside the cloud. I will also show you a completely blank cloud, and we will spin up there everything from fresh. Therefore, I need to start it first, and then we go to use cases and success stories. Use cases and success stories are for like product owner, somebody who is interested in the business, like CEOs. These parts are related to you guys, and basically this is the part which Tim will do. So he will talk a little bit small about AI and LLMs. What are the differences? What are the benefits? What are LLM good for? He will also present a lot of use cases and success stories which we made inside our company. And also that you get the feeling, what can I do with LLM? And LLM is way much more than a chatbot. So this is the stuff which he will talk about. Then we'll have a Q&A session just regarding the use cases and success stories. So not the technical part. And then we go over how to set up Olama with RAC on the Open Telecom Cloud. We talk about architecture. We will also present you our architecture, how we do things, how we also brought already things to production, which we have already live. This stuff I want to show you today. So, and then we go also over into a live coding demo, and later on there will be also a Q&A session. So For that on, this is what I want to do first. So I need to spin up GPU notebooks on the Open Telecom Cloud and to do the first initial infrastructure stuff, because it takes like 10-15 minutes and we don't have so much time. We don't have 2 hours. And that's why I will spin it up now. So first I log in. I do also here, it's also open source, it's called OTC Aus. It gives me token-based access to my Open Telecom Cloud. And basically, this is something which is, for example, necessary to get the C5 requirements. And if you want to have a high security requirement, this is also something which is required. Maybe you're thinking, like, what do I share here? I share a public GitHub project, which I will also make, or is already available for you. So it's called Terraform Open Telecom Cloud Project Factory. So here we have a lot of modules. And one of the modules is also the new one, which is the CCE and the notebooks, GPU notebooks here, this one. And also the quote, which I had just sort of opened on my software development environment, is this one. So if you go here to OTC Terraform template, we use it for educational purposes. For example, we do with HISES workshops about that. There is one branch which is called Olama Slack, and it shows you step by step how you can set up your own LLM on the OTC. So it's a really step-by-step guide, and you should easily follow it. And basically, I'm doing the same one. I just added here already my information. And what I'm doing now, I'm saying now Terraform init. So I'm initializing the backend. I use Terraform. Terraform is very cool to automate things because I want to have a high-performant environment. And therefore, I'm using Terraform as infrastructure as code to automate everything. What I want to achieve later is in the technical session, I want to have a Kubernetes cluster running, self-healing system, all the convenient things I want to have up and running. But what I wanted to show you is that we are not doing fake. So you can see it here. There is this EOD refactor. Here you can see there's no clusters, no nodes, nothing is inside there. And within like half hour or something like that, you can set up everything. So you can see here 38 resources to add, and I say yes, and he starts creating it. And that's basically what I wanted to do and what to show you. Like now it starts creating. During the creation, we will talk about business, and this is where I give over to my colleague Tim. Thank you very much.
Yes, thanks a lot, Victor. I would like to start with a nice quote from Andrew Ng, who said, "It is difficult to think of a major industry that AI will not transform. This includes healthcare, education, transportation, retail, communications, and agriculture. There are surprisingly clear paths for AI to make a big difference in all these industries." And what I really like about this statement is the clear path for AI, because I feel the same way. I talk to a lot of customers, and many people are unsure what they should do. However, we know the technology, it is there. The transformation is already happening at a lot of companies, and we can go down these paths. It's more a task of planning, and this is not in the future, it is happening now. And not only in this currently hyped field of large language models, which we will see on the next slide, I would like to give you a small idea what AI is, because it's really a vast field of techniques, and it's much more than large language models. And to give you just a hint how vast this field is, I would like to show you a few examples from our projects. I start with our smart buildings projects, where we collect data from building management system, control system, HVAC, Wi-Fi sensors, access points, and we use this data to optimize the energy efficiency for individual buildings in collaboration with simulation systems, for example. But also we have a fleet-wide decision support system that suggests renting or leasing buildings to optimize cost, energy efficiency, and worker travel time. So that's one really cool example, I think. But we also have very, very different projects like fish detection in video streams, which was a requirement by the environmental agency to count the fishes that were trapped before the power generators in water power plants. Then again, very different roster optimizations for pilot of crews, where we optimize the company's ability to fulfill the client needs, optimize 3 days of pilots, and take care of rest periods, health checks, simulated trainings. So really complex. It's really hard to do that manually, but our optimization algorithms takes care of that. And then again, a very different field, power plant reliability engineering, where our AI helps to see patterns in incidents in power plants and highlight similarities between different outages and helps the engineers to quickly solve issues and find the root causes. So please keep in mind, AI is more than just large language models, but today this talk is about large language models. So first, I want to give you a quick idea of what is a large language model. Basically, a large language model is this black box or this box in the middle here. It's gray, and it has no memory. It just has an input and generates an output. And the input is text. It can be a short text. It can be a longer text, like the sky is. And what the large language model now does is it's predicting the next word that would come there. So maybe blue could have a high probability of being the next word. So the large language model will predict blue. So, and by repeatedly predicting the next word, these large language models can now generate larger texts. And this works really, really good. As you've heard, I guess, from the emergence of ChatGPT, for example, this works really, really well. The maximum size of the prompt is called the context window, and that is a very important figure. You will hear this a lot because, yeah, this is kind of the maximum chunk size that these large language models can work on. And the best thing is, if you have in mind the machine learning projects from the past, where you had to gather lots of data and train a model, and yeah, maybe half a year later you could use it. The best thing is these large language models come ready to go. They've been trained on a vast amount of text available online and in libraries. So there's no training required usually to get them into production and make good use of them. But why is this? Why do we have this break through today and not 10 years ago, for example? And the reason is the attention mechanism. I would like to give you an intuitive understanding of what is the attention mechanism. So when you think back to school, when you were in class and you started to analyze sentences, you were marking the words and maybe detect their meaning in a sentence. Things like subject, predicate, object. This is a sub-sentence. This is the main sentence. And the interesting thing is, today we have this attention mechanism that does just that in an efficient way for neural networks. What we see here is a screenshot from a software called Dodrio. It's really cool. You can try it out online. Just Google it, and it lets you view into the large language model and see how it analyzes the text. And that is really cool. And it gives us an understanding of how they analyze the text, how they see the interconnections between different words. So what are LLMs good for? So basically, if you have a textual task that a human could do with just a short explanation and some examples, that you can also give to a large language model. So understanding and extracting information from texts, summarizing, comparing texts, that's perfect work for a large language model. Summarize and compare text, that's also good. Mood, sentiment, general style detection, really cool. Works really good, but not just the style detection, also generating good looking content. For example, I come from software engineering. We've seen a lot of lorem ipsum texts in the past when we did prototyping, but today we don't do that anymore. We throw in very realistic texts from large language models. Also, you can, and regarding the style detection, you could think of a large language model that analyzes the text that your customer-facing people write to customers and analyze, does this really have the correct style that the company wants? And you can, with this, make sure all your text and customer communication is written in the same style and idea. Also, large language models can adjust the style. So if you write a text, it can transform it and say, okay, rewrite this text, please, as if it were written to a friend. And you could think of this, maybe even generating personalized texts to all your customers based on what you know about them. Then again, it's also good to get feedback. We are doing this, for example, in software engineering with Copilot. That's just one example where it analyzes the code and does smarter predictions than we ever had before about what code I want to write. It's really cool and works in a good way already. But then, of course, there are some points where you shouldn't use large language models. And for some people, this might be surprising because we are used to computers being good at calculation, for example. Computers were always good at being definitive, having the correct answer. And the very structure of large language models now means that they can't do that really good. So it's not a calculator, and you shouldn't use it in that way. It's also, when it comes to decision making in general, and especially when it comes to medical advice, for example, you have to see that large language models have not been trained in the real world or in a simulation model of the real world. They are just trained on text. So it's like this bookworm who has read the whole library but has never treated a patient. So that doesn't mean it doesn't know anything, but you should be careful when asking it for advice. And then again, for example, database queries. A large language model is not a SQL engine. It can quickly deceive you with good-looking results. Please don't use it like that, at least not directly, and we will come to that shortly. Also, I've seen a lot of posts online about some stock picks with ChatGPT and so on. Please, large language models have no crystal ball, and they are no crystal ball. They don't know the future. They are not trained to do database predictions. So even if you would give ChatGPT data to do forecasts, as you could do with normal machine learning algorithms, it won't do a good prediction. So don't use it that way. I mean, your gut is probably more data-driven in that sense than the large language models. However, given all these points, we can still combine large language models with specialized systems for such tasks. So you could combine large language models and their unique ability to interface with humans via text with a calculator, with an equation solving mechanism, with a specialized service that provides medical advice, with optimization algorithms that support decision making, and with SQL engines to do database queries. And that's where we come to what is sometimes called augmented generation, where we build a system around the large language model. So it's not just the large language model, but the large language model is the essential part. So the prompt is fed to an orchestrator, and this orchestrator can now do several things. It can look in a database for relevant entries regarding the prompt. It can interface with various services, for example, for calculation or like medical advice or whatever. It can do multiple queries to the large language model regarding that prompt. And in the end, it can collect an answer that comes from the large language model. It has all the benefits of that, but it has this additional accountability of the specialized services and the database entries. This is really a game changer. And one version of this augmented generation is the retrieval augmented generation, which mainly does this database lookup. Now I have some example use cases I would like to show to you. For example, we have this project about broadband tenders together with the telecom. In Germany, each local authority must create their own broadband expansion tenders to get funded. And you can think of them, every one of them writes their own tenders. In Word, all of those documents look different. And each tender is a collection of documents with reference to funding programs, to various funding programs, to addendums, whatever. And these tenders have to be screened for key facts to prepare an evaluation and further processes by all the broadband companies. And a good employee needs multiple hours to extract the key facts of just one tender. So there's a lot of effort required to extract this information. So we built a system that where you can upload these documents regarding a tender. And we are now extracting key information from these tender documents. It's not a chatbot. The people don't need to chat. That would be, again, a lot of effort for the people to enter all the questions, but this is all done in the background automatically. They always need the same key facts to extract it for all the tenders. And there's a possibility, for example, to do manual corrections. And also the main feature, I think, to get the support of the business department here was a feature to show the source of our answer. It gives you the text from the original document, and highlighted is the relevant piece of information so that an employee can quickly see where does this information come from, why is this the correct answer. And this really is a time saver. For another client, we had to build a POC for an internal knowledge base about logistics. You can think about it as an FAQ, like chatbot solution. And in this example, we fed it with the DHL terms and conditions. As you see here, we have a chat interface, and we ask the bot what are the standard working hours for a DHL. And it says, okay, based on the question, I chose the data input DHL standard terms and conditions, and it answers the standard working hours for DHL are from Monday to Friday, 8 to 1800. Yeah, so it works well. Such FAQ chatbots are really something where we get a lot of customer queries right now. And you can think of this, and this is very simple here, but we also have much bigger inquiries regarding gigabytes of documents, and we've done this with thousands of documents. Another demo in the health section. So the idea was to allow doctors to quickly find the important information about patients, because there are so much documents around patients, and you really want to quickly find what you are looking for. In this example, so on the right side, you see the document. This is a patient, Pamela Rogers, and she was diagnosed with hypertension 3 years ago. And we will just ask the chatbot a few questions. This is a real-time video, so you also see how fast it is. First question, how old is Pamela Rogers? She is 56 years old. And now we asked, was she diagnosed with hypertension? Yes, according to the provided context information, she was diagnosed with hypertension 3 years ago. And now comes a question that is debatable. I earlier told you, you shouldn't ask an LLM about medical advice. And in this case, I want to highlight, this is meant for doctors. So a doctor is an expert in his field, and he or she knows if it's bullshit or not, frankly put. We as a layman don't know. So in this case, we get a really long answer. I think it looks good, but I am not a doctor, and a doctor just can ask the bot to get maybe some inspiration. What would be a standard treatment here? And with that, I would like to hand over to Victor shortly, but first we have some time for Q&A.
Yeah, any questions so far?
Yeah, first one was Tristram. Yeah, please.
Hello from my side. I was just wondering about this. I mean, it's obviously really cool technology, and my question was basically, what would be needed to set up a knowledge base with this kind of LLM, which is basically searchable and gives you the references to this knowledge base? I'm thinking about something like getting some facts about the product, for example, and basically just to have a big collection that you can at the end, for example, also export maybe into a file if somebody requests some, your whole data about the product. Is that something that you would see in this kind of scenario, or is that something where you would say it's technology-wise maybe a wrong direction for this kind of tool?
Yeah, I think especially the first part that you mentioned. So querying for information about your products. If you have a large body of texts about your products, product presentations, for example, and you could feed an LLM these documents and query that, no problem. You can let the large language model also summarize parts of those texts. Yeah, I think there would be maybe some development needed to make sure that the summaries really contain all the information that you want. Because doing that in a naive way can lead to just having small pieces of the information and not capturing exactly to the point what you want to have. But that's certainly doable. Yes. So if you would like to talk about that, we're happy. Just contact us.
What we currently use, I think we are talking not about the LLM, what's like the pre-trained model, but the data which we ingested there. So basically we have different input pools where we get the data from, and there you can also define access rules or how to access the data, retention policies and stuff like that you can define. And basically this is something which we then work out with the client together. I think it will be also more clear later when we go a little bit into the technical part where I show you the technical stuff.
Yeah. Okay. So I will wait for that basically, and maybe I can get or ask a more precise question than this just rather teaser. Yeah. Okay. Thank you.
Thank you, Tristram.
Yeah. Thanks.
Yeah, Toby.
Thanks a lot. So you may have heard the question a lot in the past, but are you using any external APIs like OpenAI? And what about masking those data? So I heard you mention an example providing a tender document, but I would avoid exposing those data through the network.
You don't want to expose it to the internet. Yeah, this is exactly our case. So what we're doing and what I will also show you now and what you can also redo. So basically you can set up Olama in the private infrastructure. So basically you have your data there, you have Olama, you have to track everything inside your infrastructure, nothing goes outside. So basically you can do also the firewall rules and everything defined like that everything keeps inside, especially for the medical department. It would be absolutely no-go if some data would go to the internet. So Olama offers the API to OpenAI, but basically in our cases, we set up every time a secure environment and a private environment, therefore no data goes out. And also, I think it will be clear when we're going a little bit into the technical part.
Then maybe one last question here for this Q&A session, which is connected to your answer, Victor, right now from the chat from Julina. This is how is the GDPR applied in the LLM here, which you've showed?
I think the main answer is that the data stays in your infrastructure.
Exactly.
So in that way, you have the data at your hands. I mean, it can get tricky if you would hand personal data to ChatGPT, for example. Yeah, you're not allowed to do that. So you have your data at your hands, and so you can treat it as you would in any other of your applications.
These questions are perfect for me because they're just going directly into my next 2 slides. So this is the perfect takeover, or like when he's loading. So ChatGPT changed our way of working in our lives, but we have some problems with GDPR compliance. We have problems with data privacy. The data goes, I don't know where, because it's a US company. And it's also not possible to add private data on a very big, large scale. So you cannot just pump gigabyte of data, define access rules and all the stuff. This is really hard to do. And this exactly where Open Telecom Cloud plus Olama, which we are using, is a very good fit. Olama is an open source tool. And basically, I want to explain you a little bit about Olama, what it does, because we are very big fans of that. It's a tool to set up your LLM run locally. It supports, for example, Llama 2 from Meta and many, many more models. They're adding every day new stuff on that, and also OpenAI connection you can also define. But basically, this Llama 2 and like this local stuff, this is something which is very, very interesting. So it's also very easy to use, like to setting up the initial things. So you have some small at-home setup to working. This is really easy to do, and it has also some very cool free web UI which you can use. I will also show you the project. So this, if you go to olama.com, you can see here, this is the with Llama 2, and basically it's available for macOS, Linux, Windows, and also for container environments. And this is like the very important thing. If we go back to our Terraform code, because I said I needed to start something and now it went through, I want to show you also everything here. So this is the first initial yes, which I pressed in the beginning of the presentation. And then it created for me GPU notebooks and all the things, and the NAT gateways, the Kubernetes cluster it created for me, some DNS entries. But this is very easy to use, and basically you can also use it at your home. And later on, I sourced the stage dependent environment. So I used OTC aus to get my Kubernetes config. So I have token-based access. And if I say kube control get pods -a, then hopefully I see my pods. Yeah. To show you, earlier I used the UI, and you can see it also here. We have here now the new Kubernetes cluster, which was not before there. And also I want to show you that we're using GPU nodes. So you can see here, this is the GPU P2X large 4. And we have 3 more nodes because we want to have a Kubernetes cluster running. Because the interesting part is, how do I get this one to production ready state? And this is what I wanted to show you today. So the second part is installation, not of the infrastructure itself, but the Kubernetes part. And this is exactly how I set up the infrastructure. If you want, for example, to try the infrastructure at home, then, as I mentioned before, you can go to OTC Terraform template. There's a branch Olama with RAK. It gives you a step-by-step guide what you need to do. And the most important thing is that you fill out this information, which are here in the N4C. There are some replacements, and if you replace this one and source this file, you can directly go with Terraform init and Terraform apply and start booting up the infrastructure exactly as I did. So this is everything open source. Take everything and use it how you want to use it. Now we go here into the second part, because we want to bring some life inside our Kubernetes cluster. Here I'm doing the same. So first I will start the deployment, and then I will go into the discussion or explain you how we do things and what I want to apply now, or what will be applied now. Since everything infrastructure as code, should be very easy for you to replay it. So we wait 1 second. It needs to install a lot of things on our newly fresh Kubernetes cluster. As you saw before, also we had not much pods running. We had just like the default one, which are coming from Open Telecom Cloud, and now we want to bring there way much more pods, and also our Olama we want to run there, and also with RAK, which is the most important part. So let's take a look. So there's some checks. Some KMS encryption, because we want to encrypt all of our data. We need ingress controller. If you know, Kubernetes is for loading the traffic. And also, most importantly, we want to have our Helm release Olama. So I press yes. And what we do now is I will build up exactly the same stuff which we had for the medical showcase. So if you go now for refactor ITS tech, you see there's nothing running here, and we will bring some live into it later. What do we have first? So we have a user, and the user goes to Ollama Web UI. This is the front end. So this is the chatting platform which you saw on the medical showcase, and behind there is Ollama. So there locally runs the LLM on GPU nodes, and this is the basic setup. So this part here. But the very interesting part is then also how do I get RAG inside there? So how do I ingest my data there? For sure, if you're AI developers, you know Llama Index and some other tooling which you can use there, but you need to develop all of these connectors. And what about like logging, monitoring, alerting if something goes wrong? What about I want to get new data every 5 minutes? So you need to develop all of these connectors. And there we said there should be, there is a tool already which we use in the infrastructure and in the cloud ops department already for a long time, which is called Airbyte. It's an open source tool, ETL tool, which can get you all of this data, and we can use it then inside our LLM. So what we do, we use Airbyte. We installed also on our Kubernetes cluster. It will connect to databases, PDF documents, and many more text documents, whatever you have. It has over 300 connectors where you connect to data. And we push this data then to VV8. So the Airbyte connector pushes data to VV8. And we have a custom middleware. This custom middleware I will not show today because this is like the key point of our ITS AI. So this one is the private one. But basically, you can also redevelop if you want it in a small case. But if you want to have like a very full-blown solution with, I don't know, image recognition and all the stuff, then I would recommend that you maybe use our solution, our private one. But basically, what does the Ollama Web UI before it goes to Ollama? We use a custom middleware. This middleware makes the decision from the VV8 database which kind of data input stream do I have at the moment. So for example, we have the question, and based on this question, our middleware decides which kind of input stream is the right one to answer our question. And also in the middleware, we use also OTC and OAuth, so it respects also our role-based access inside our company. Therefore, you can decide, for example, the finance department cannot see, for example, customer data or data from the software development department or something like that. And this is a really cool setup. One of our developers also just connected his local IntelliJ, it's a software development tool with Ollama. So he doesn't use OpenAI anymore, but uses directly our private Ollama so that he can work also on more critical projects, because in this kind of projects, we are not allowed to use OpenAI. This is the kind of blueprint and like big picture which we have. And how does it look like in the Open Telecom Cloud? This looks like this. So in the left part, you can see the stuff which we deployed. So it's infrastructure. There's the Kubernetes cluster. There's the GPU node pool. We run everything on the Open Telecom Cloud. And this is the Kubernetes folder. There runs Helm inside. And with Helm Terraform, we deploy these things. I will quickly open IntelliJ again. So you can see here's the Kubernetes folder. And here is my infrastructure, like the things which we have here: SNAT, Kubernetes cluster, CCE, GPU node pool. And in the Kubernetes part, we have done the deployment, so the Helm charts, the container itself. We deploy with the Helm Terraform provider. We deploy some custom resource definition. Traffic is about the routing, so the routing goes the correct way. We use also Kyverno to enable policies. We have also Cert Manager to have automatic certificates for our domains, and storage classes for encryption. And also, this is like the top one, and the left one, if you watched one of my other videos about infrastructure, it looks very similar to what I do on previous talks. But this time we have a little bit more. So we have the Ollama Web UI, which is the front end. We have the VV8 for storing the sensitive data, so back to GDPR compliant. And also we use Airbyte to add the data. And later on, we have also the middleware, which is our private things where we make these decisions, like to which data input stream I should go to fetch my data. And basically also, is my question valid and stuff like that. So these are the parts, and now let's see if this thing is running. So it's still creating, so it should boot some things up. What I will do now is I will open here a new terminal, kube control. This is what was previously, so you can see there was not much on our Kubernetes cluster. And now we have a lot of things. If you want to do it with Docker, it's very easy. It's just like a single command. Just type it in. It's not much what you need to do because Ollama makes it very simple for you. But to have like a real production environment and to have like this auto scaling and all the things up and running, then Kubernetes makes that totally sense. And if you're doing this part, you have a LLM locally running without a problem. So we need a little bit more time. And then hopefully our LLM is running. Kube and SLM, kube control get pods. This is a live demo. Therefore, every time something can go wrong. So but in most cases, it's absolutely no problem. Everything works smooth. But let's take a look. What is inside there? Maybe it just needs a little bit more time. Yes. Lack of GPU device information. Okay. I would like to switch now for the Q&A session, and we will give it a little bit more time to boot it up. So does anybody have some questions to the technical part?
Yeah, I think regarding the technical part, there are some questions in the chat part here. That's more an AI question. That was by Mark Roberts. GDPR also covers deletion. How can this be managed on a trained source? The main thing is we don't train. The large language model comes pre-trained based on public sources on the internet and from libraries and so on. So we don't train the large language model on your data. And that means you just have to delete the source files as well as the entries in the vector database. And that could be done by a connector from Airbyte, for example, or whatever system you want to use. And then the data is gone, and there will not be any reference to that piece of information anymore in the system. So it's quite easy to cover this deletion part.
I see one raised hand from Patrick. I will shortly give you the privilege to unmute.
Hello, thank you. First, the presentation was great, so thank you very much. I have a question regarding something in a little bit maybe a business context. I'm trying to implement a Python tool using the that currently only supports that is made to use ChatGPT, OpenAI API, and currently has not really support for custom models. And I'm not super deep into the LLM programming part yet. So do you have any recommendations? Can I use this tool in this local environment as well? Or how many modifications are needed to change up? Because I think it would be something that would really help our department. And I think, yeah, I want to focus on that kind of in my downtime, I guess. So yeah, if you have any input, how easy it is to adapt to local models, or if it works with this, then I would love to give it a try. Yeah.
What do you mean with executing the large language model locally, or what do you mean with this tool? So if you are referencing Ollama, for example, you can also choose a simpler version of the infrastructure that Victor is presenting and just run Ollama locally. And Ollama is this chat interface as well as the backend where you can configure what LLM it should run on. And that's quite handy if you want to try out maybe various open source models like Llama 2 or some Mistral or Mixtral model, for example, or the new Google models. That's really handy and it helps a lot, I think. Yes, that's quite easy to set up.
Yeah, because I was because the the tool is currently just working by easily exporting your OpenAI key, but that is not really a solution that we in my department want to focus on because it costs us money. It would be easier if we could use a self-setup LLM or some kind of copy or something locally that we can do, especially because we're in a highly secure context. So, and I don't have a lot of experience in that. So I was just asking how easy it is to substitute the one line of export your open API key here into hosting something locally, but with a similar tool or the same tool. Like, is it, how easy is it to change that up from the basic OpenAI API?
I think it also depends on your Python program. So in our cases, we use Llama Index. That's a Python framework that easily allows you to switch out the large language model. And we have a lot of colleagues who switched out OpenAI with our own hosted large language model. And that works quite fine and easily.
And I think when there are more questions open, you can also get in contact with Victor and also Tim via email. You have the contact details in the slides here. They will be also uploaded in the OTC community after this session here, so then you can pick them up. With an eye on the timer, Victor, how do you need more time here, or can we switch again to you?
Unfortunately, we need a little bit more time, so like 2-3 minutes. Maybe one more question.
All right, we have one question here, Stanislav.
The first one, which I would like to ask is, why did you actually choose to use the Airbyte? Because is there some specific features which it makes it much better for the usage of the applications or some tools compared to, I don't know, Airbyte, Airflow or Duckster or something else? And the second one, which I wanted to ask, is about the choice of the V8. And did you have some time to compare it to some other vector databases, or like the V8 is the right tool for you to go for? And then
basically, I can answer this question. Airbyte we use already in multiple other projects, so we had good experience. For example, you want to have like nightly every time to sync the data, and if a customer, for example, does not want to develop the connector, so he should be able to easily define the connector by himself. And since we're in the infrastructure, have a lot of good experience with Airbyte, we went with Airbyte. And also I saw some article where they did similar to us, not as like scaling so much solution as we have, but they used V8 and also Airbyte. There was an Airbyte article about that. This one I read, and basically this one I took then over as the first initial steps. Then we went with V8 because, exactly as was mentioned there, in the end we customized the connector to V8 a little bit, so we wrote our own destination. But basically I can show you also how easy it is then to connect some data, to add some data. So this, for example, then our demo case, and you can see here under sources, you can just select then, for example, you want to have S3 buckets, which you use for Open Telecom Cloud, or you want, for example, GitLab, so you can build up your own developer knowledge base, or GitHub. So you just can connect this one and add the stuff here. And this destination we have every time. This time it's called ITSAI because we customized the V8 connector, but in the first initial approach we took V8 connector, but the V8 connector was the open source one was not efficient enough for us. And then in the connections you can just combine this both, the source and the destination, and you can sync the data however you seem fit.
Regarding the comparison to other vector databases, I think this is really an emerging field right now. We are missing some functionality from V8 that is in their development pipeline, definitely. We are looking at alternatives in other projects. We use Chroma, for example, to have an in-memory vector database. But in my mind, V8 is already further in this direction of being a standalone database that runs, because Chroma just runs in the background of your service, for example, but then you have to take care of data persistence and so on. So it's really an emerging field where every week we get further ideas and impressions, and we look at alternatives all the time. Yes.
Okay. Thank you very much. Thank you.
Thanks for the question. So yeah, so you see, it's really a live demo, and sometimes when you have a limited time slot here, this is not always fitting in the time slot, but let's see what we can still make happen.
It's still booting up, but basically we need a little bit more time, and you can see it here. So we got the domain already, page not found, but you can see here the pods are now up and running. So we have also Olama. It restarted, but here we had them. Where was it? Oh, so it's still booting up. We need a little bit of more time. The Olama web UI is there, so we should be able to log in. Yes, there it's coming. Whew! Just 2 minutes late, yeah. So we click sign in, we say Victor gets, we use any password which we have. I hope the Olama is now also up and running. Yeah, it's also up and running, amazing. So create account, you're logged in, and you can see the full UI. And this is a little bit older version, but we will also release a newer version. So if you want to enable a RAG, then you can use this flag, which is called use VV8 as input data. And if you make this one to on, you're chatting with your own data. So you add your data. And if you have to off, then use the normal one, so without. So what you need to do first in Olama is you need to select the model. So I need to go to model and say, for example, Mistral 7B. You can also use OpenAI if you want to. So if you have public data or not sensitive data, then you can do this one also. But I think for most of you guys, also Hugging Face is also supported. So you can add here download URL or some local files, but I would just recommend download URL. So it downloads our modules here. It's Mistral 7B. We need to wait 2 more seconds. We have also certificates, we have routing, we have container environment. So this is really a lot of stuff for 1 hour. And now it should be fine. No? Did I was too fast? I was too fast. Now it's there. Nice. So we select Mistral and we just make a simple dummy question. Tell me a fun fact about the Roman Empire. And it takes a little bit of time because this is the smallest GPU which is possible on Open Telecom Cloud. But if you use a little bit more money, then it's absolutely no problem. You have more performance there. You can also add here local things, which is also very cool. So basically, if you use Airbyte and the VV8DB, you can ingest a lot of data. But if you have maybe 1 or 2 documents which you want to upload, you can use also this upload button and upload then some of your documents, and then it puts it into the context. So finally, yes, I was a little bit worried it was not working this time, but yeah, it worked. You can use multiple modules. Mistral, also embedding modules was added, I think, last week. So Olama is a really, really cool tool. I would highly recommend it.
All right. Thank you.
Thank you very much.
And also thank you, Tim, here for having you here in this great webinar. We made it almost just in time here. So I think for your own LLM model, when you take 2 more minutes than planned for the build up, this is totally fully acceptable. So I hope you had a great time together with us here. When you have any questions later on, we have the contact details of Victor and also Tim in the presentation, which will be uploaded in a few minutes also in the OTC community. So when you have any questions, just get in contact with them or also post a question in the OTC community directly. So thank you a lot for joining. Wish you a nice weekend and see you in one of the next OTC webinars. Thank you a lot. Bye.
Thank you. Bye-bye.
Thank you, everyone.